The story of British aviation after World War II represents one of the most fascinating and bittersweet chapters in aerospace history. Great Britain emerged from the Second World War victorious but economically exhausted, its cities damaged by bombing, its treasury depleted by 6 years of total war, and its empire beginning the inevitable process of dissolution. Yet despite these challenges, British aviation stood at the pinnacle of technological achievement in 1945. British aircraft had played crucial roles in victory, from the Spitfires and Hurricanes that won the Battle of Britain, to the Lancasters that carried the strategic bombing campaign to Germany, from the Mosquitos that proved the versatility of wooden construction, to the Meteors that represented the first operational Allied jet fighters. British engineers and designers possessed world-leading expertise in aerodynamics, jet propulsion, radar, and numerous other technologies that would define post-war aviation. The immediate post-war years saw British aviation industry poised for what many expected would be a golden age. Frank Whittle's jet engine technology gave Britain a commanding lead in the jet age that was dawning. British designers conceived ambitious projects that would push the boundaries of speed, altitude, and capability. British aircraft manufacturers, including Hawker, Supermarine, de Havilland, Avro, English Electric, Gloucester, Bristol, and others possessed tremendous engineering talent and production expertise. The Royal Air Force, having proven itself one of the world's premier air forces, required modern equipment to meet its commitments, defending British interests globally and contributing to NATO collective security. British military and civil aviation seemed poised for decades of success building on wartime achievements. The reality would prove more complex and often disappointing. British post-war aviation achieved remarkable successes, including pioneering jet airliners, producing innovative aircraft designs, maintaining technological leadership in specific areas, and creating aircraft that served with distinction for decades. However, the story is also marked by programs canceled before reaching service, brilliant designs produced in numbers too small to achieve economic success, the gradual consolidation of British aerospace companies as financial pressures mounted, and the eventual recognition that Britain could no longer afford to develop major aircraft programs independently. By the 1960s and 1970s, international collaboration would increasingly characterize British aerospace, with programs like Concorde, Tornado, Jaguar, and eventually Eurofighter Typhoon, representing shared development with European partners. This comprehensive examination covers the major British military aircraft developed and operated after World War II through the end of the 20th century. We will explore fighters and interceptors, bombers both conventional and nuclear, trainers, transport aircraft, maritime patrol aircraft, and helicopters that serve the Royal Air Force, Royal Navy Fleet Air Arm, and Allied nations. Each aircraft will be examined not merely as a technical artifact, but in its operational context, exploring how it served, what missions it performed, and how it contributed to British defense and aviation history. We will discuss the triumphs and failures, the innovations and dead ends, and the evolution of British military aviation from the confident years immediately after 1945 through the consolidation and collaboration that characterized the later Cold War period. This is the story of British military aircraft in the jet age, a tale of remarkable engineering achievement constrained by economic reality, of innovation and adaptation, and of an aviation industry that, while no longer dominant as it had been during the war years, continued producing aircraft of genuine significance and capability. The de Havilland Vampire represents one of the most significant British aircraft of the immediate post-war period, serving as the Royal Air Force's second jet fighter after the Gloucester Meteor and becoming Britain's most widely exported early jet aircraft. The Vampire's distinctive twin-boom design made it instantly recognizable, while its relatively simple construction and docile handling characteristics made it an ideal transitional aircraft, as air forces around the world moved from propeller-driven fighters to jets. Development of what would become the Vampire began during World War II as a company-funded private venture by de Havilland. The design utilized a single de Havilland Goblin centrifugal flow turbojet engine, which was less powerful than the axial flow engines being developed, but more reliable and easier to produce with 1940s technology. The distinctive twin-boom configuration was chosen to minimize the length of the jet pipe from engine to exhaust, reducing pressure losses and simplifying construction. The nacelle housing the engine and cockpit was constructed using de Havilland's extensive experience with wooden construction, incorporating ply and balsa wood in a composite structure that was lighter and easier to produce than all-metal construction while providing adequate strength. The prototype DH-100, as it was initially designated, first flew on September 20, 1943, demonstrating excellent flying characteristics and good performance, despite the limited power of early jet engines. The aircraft's handling was docile and forgiving compared to earlier jet designs, lacking the nasty characteristics that made some early jets dangerous for inexperienced pilots. Visibility from the cockpit was excellent thanks to the bubble canopy and low-mounted engine nacelle. The simple construction meant that production could be established relatively quickly and easily compared to more complex all-metal jet designs. The Vampire entered RAF service in 1946 as the Vampire F-1, initially equipping No. 247 Squadron. The early production Vampires were powered by the de Havilland Goblin II turbojet, producing 3,100 pounds of thrust, giving the aircraft a maximum speed of approximately 540 miles per hour at altitude, adequate for the immediate post-war period, though already being surpassed by more advanced designs. Armament consisted of 4 20mm Hispano cannon mounted in the nose, providing concentrated firepower, though limited ammunition capacity. The aircraft's range was modest, approximately 730 miles with internal fuel, reflecting the fuel consumption characteristics of early turbojets and limiting operational flexibility. The Vampire F-3, which appeared in 1948, incorporated various improvements, including a pressurized cockpit, increased fuel capacity, and provision for external fuel tanks, addressing some of the earlier variant's limitations. This became the primary RAF fighter variant, eventually equipping numerous squadrons. The Vampire FB-5 fighter bomber variant featured strengthened wings capable of carrying external stores, including bombs and rockets, expanding the aircraft's mission flexibility. This variant proved particularly popular for export, serving with air forces around the world. The Vampire's export success was remarkable for a British aircraft of this era. Over 20 countries operated Vampires, including Australia, Canada, New Zealand, South Africa, India, Switzerland, Sweden, Italy, France, and numerous others. Several nations established licensed production, with de Havilland Aircraft of Australia, Fiat in Italy, SNCASE in France, and other manufacturers building Vampires domestically. Total production exceeded 3,200 aircraft across all variants, making the Vampire one of the most produced British jets of the early post-war period. This export success provided valuable foreign exchange earnings for Britain and established relationships that would benefit future British aircraft exports. The Vampire's operational service with the RAF was relatively brief as frontline equipment. By the early 1950s, more capable swept-wing fighters, including the Hawker Hunter and Supermarine Swift, were entering service, relegating the straight-wing Vampire to secondary roles. However, the Vampire found a successful second career as a trainer. The Vampire T-11 two-seat trainer variant, featuring side-by-side seating in an enlarged and redesigned cockpit, became the standard RAF jet trainer from 1952 through the early 1970s. The docile handling characteristics that made the Vampire a good fighter for pilots transitioning to jets made it an excellent trainer for introducing student pilots to jet operations. The T-11 trained virtually every RAF jet pilot for 2 decades, providing reliable and economical service that far exceeded the single-seat fighter variants. The Royal Navy also operated Vampires, with the Sea Vampire being the first jet aircraft to land on and take off from an aircraft carrier, achieving this milestone in December 1945. While the Sea Vampire did not enter operational service in significant numbers, it proved the feasibility of jet carrier operations and provided valuable experience that would inform subsequent naval jet development. The Vampire never saw combat with the RAF, though export operators used the type operationally. The Egyptian Air Force operated Vampires during the 1956 Suez Crisis, engaging Israeli aircraft. The Rhodesian Air Force used Vampires in counterinsurgency operations during the Rhodesian Bush War. Various other operators employed Vampires in conflicts and skirmishes, generally finding the aircraft adequate for operations against opponents lacking sophisticated air defenses or modern fighters, though clearly obsolete for high-intensity air combat by the 1960s. The Vampire's significance extends beyond its operational service. It demonstrated that jet fighters could be produced relatively economically and operated from existing airfields without extensive infrastructure modifications. Its export success showed that British aviation industry could compete effectively in international markets. The two-seat trainer variant proved that a well-designed aircraft could find success in roles beyond its original purpose, with the T-11 serving decades longer than anyone anticipated when it was designed. The Vampire's wooden construction represented the end of an era, as subsequent British jets would be all metal, but it proved that unconventional materials and construction methods could produce effective jet aircraft. The Gloucester Meteor holds the distinction of being the only Allied jet fighter to achieve operational status during World War II, though it arrived too late to significantly impact the war's outcome. However, the Meteor's true importance lies in its post-war development and service, where successive variants evolved the basic design into an effective fighter and fighter-bomber that served the RAF through the 1950s and numerous export customers for decades beyond. The Meteor's wartime service was limited, with the aircraft entering squadron service in July 1944. Early Meteors were used primarily for defense against V-1 flying bombs, where their speed advantage over piston-engine fighters proved valuable. However, wartime Meteors suffered from limited engine reliability and modest performance, with the centrifugal flow engines producing insufficient thrust to make the aircraft truly competitive with the best piston fighters in many regimes. The end of the war saw relatively few Meteors in service, but the type's potential was clear. Post-war development transformed the Meteor into a much more capable aircraft. The Meteor F-3, which entered service in 1945, incorporated longer nacelles housing improved Rolls-Royce Derwent engines with substantially increased thrust, a sliding bubble canopy replacing the original frame canopy and improving visibility, and various aerodynamic refinements. Maximum speed increased to approximately 493 miles per hour, a significant improvement, though still modest compared to what would soon be achieved with swept-wing designs. The Meteor F-4, introduced in 1948, brought more substantial changes. The fuselage was lengthened to improve directional stability, the tail surfaces were redesigned, and further aerodynamic improvements were incorporated. The Derwent 5 engines produced 3,500 pounds of thrust each, pushing maximum speed to around 585 miles per hour at sea level. The F-4 became the primary RAF fighter variant in the late 1940s, equipping numerous squadrons and providing the bulk of RAF fighter strength during the period before swept-wing fighters entered service. The Meteor F-8, which appeared in 1950, represented the ultimate single-seat fighter development. This variant featured an enlarged cockpit canopy with better visibility, ejection seat as standard equipment, increased fuel capacity extending range, and provision for underwing stores including drop tanks and bombs. The F-8 became the definitive Meteor variant, with over 1,100 produced and serving as the RAF's primary day fighter until replaced by the Hawker Hunter in the mid-1950s. The Meteor NF-11 night fighter variant, developed from a private venture by Armstrong Whitworth Aircraft, featured an elongated nose housing AI Mark 10 radar, a two-seat side-by-side cockpit with the pilot and radar operator, and Derwent 8 engines. The night fighter Meteors served from 1951 through the late 1950s, providing the RAF's primary night and all-weather fighter capability until replaced by the Gloucester Javelin. The night fighter variants proved valuable during a period when air defense against potential Soviet bomber attack required around-the-clock capability. The Meteor FR-9 reconnaissance variant featured a lengthened nose housing cameras, provision for underwing reconnaissance pods, and strengthened structure for low-level operations. The Meteor FR-10 was a reconnaissance version of the F-8 with similar capabilities. These reconnaissance Meteors served into the late 1950s, providing tactical reconnaissance capability until replaced by more modern types. The Meteor saw combat service during the Korean War, where No. 77 Squadron of the Royal Australian Air Force operated Meteor F-8 US, from late 1951 through 1953. The combat experience proved sobering. While the Meteor performed adequately in ground attack and fighter bomber roles, air-to-air combat against Soviet-supplied MiG-15s demonstrated the straight-wing Meteor's inferiority. The MiG-15's swept wings, more powerful engine, and superior high-altitude performance gave it decisive advantages. Australian Meteor pilots found themselves outclassed, suffering significant losses when engaging MiG-15s. The Korean experience demonstrated conclusively that the straight-wing first-generation jet fighters like the Meteor were obsolete for air superiority missions against modern swept-wing opposition, accelerating the transition to more capable fighters. Despite combat limitations, the Meteor achieved significant export success. Over 15 nations operated Meteors, including Argentina, Australia, Belgium, Brazil, Denmark, Ecuador, Egypt, France, Israel, Netherlands, New Zealand, South Africa, and Syria. Several nations, including Argentina, Belgium, France, and Netherlands, established licensed production. Total Meteor production exceeded 3,900 aircraft across all variants, making it one of the most produced British jets of any era. The Meteor set numerous speed records in the immediate post-war years, becoming the first jet aircraft to hold the world airspeed record. In November 1945, a specially modified Meteor F-4 achieved 606 miles per hour, and in September 1946, another Meteor pushed the record to 616 miles per hour. While these records were soon eclipsed as jet technology advanced rapidly, they demonstrated British aviation's technological leadership in the early jet age and provided valuable publicity for British aviation industry. The Meteor's service with the RAF ended in the early 1960s as more capable aircraft replaced it in all roles. However, export customers operated Meteors much longer, with some air forces flying the type into the 1980s in training and secondary roles. The longevity of service, particularly in export markets, testified to the basic soundness of the design and the value provided by this first-generation jet. The Meteor's historical significance is substantial. As the only Allied jet fighter to see wartime service, it represented British aviation's successful development of operational jet fighter technology during the war. The post-war development demonstrated how an adequate wartime design could be substantially improved through incremental upgrades, though the Korean War experience showed the limits of such evolutionary development when facing revolutionary designs. The Meteor's commercial success, particularly in export markets, demonstrated British aerospace industry's ability to compete internationally and establish relationships with foreign air forces that would benefit subsequent British aircraft programs. The night fighter variants showed how specialized versions could extend an airframe's usefulness beyond the original fighter mission. Perhaps most importantly, the Meteor provided the RAF and numerous Allied air forces with their first operational jet fighter experience, establishing procedures, training programs, and operational concepts that would inform the employment of subsequent jet aircraft. The Hawker Hunter represents perhaps the most aesthetically beautiful fighter aircraft ever produced and arguably the most successful British jet fighter of the Cold War era. The Hunter combined elegant lines with excellent performance, superb handling characteristics, and versatility that allowed it to serve effectively in fighter, ground attack, reconnaissance, and training roles for over 4 decades with air forces worldwide. The Hunter's grace in flight and forgiving handling earned it adoration from pilots, while its combat record with multiple air forces demonstrated genuine effectiveness. Development of the Hunter began in the late 1940s as the RAF sought a swept-wing day fighter to replace the straight-wing Meteor and Vampire. Hawker's design team, led by Sir Sidney Cam, who had previously designed the legendary Hurricane, created an aircraft around the Rolls-Royce Avon axial flow turbojet engine. The resulting design featured a single engine, swept wings and tail surfaces, and clean aerodynamic lines with minimal protrusions or disruptions to smooth airflow. The prototype P-1067, as it was initially designated, first flew on July 20, 1951, and immediately demonstrated excellent performance and handling characteristics. The Hunter F-1, powered by the Rolls-Royce Avon 113 engine, producing 7,500 pounds of thrust, entered RAF service in July 1954 with No. 43 Squadron. Early production Hunters mounted an armament of 430mm ADN cannons, providing devastating firepower, though limited ammunition. The aircraft's maximum speed exceeded 710 miles per hour at sea level, making it one of the fastest fighters in service at the time. More importantly, the Hunter's handling was superb, with light, responsive controls and none of the unpleasant characteristics that plague some contemporary fighters. Pilots universally praised the Hunter's delightful flying qualities, which made it both an effective fighter and an exceptionally safe aircraft with a remarkably low accident rate. The Hunter F-2, powered by the alternative Armstrong Siddeley Sapphire engine, entered service alongside the F-1, but proved less satisfactory due to engine supply issues and inferior performance compared to Avon-powered variants. The F-2 was relatively short-lived in RAF service, though some were later upgraded and continued serving in other roles. The Hunter F-4, introduced in 1955, featured the more powerful Avon 115 engine and provision for external stores including drop tanks and bombs, enhancing both range and ground attack capability. The F-5 was similar to the F-4, but Sapphire-powered. These variants addressed the most significant limitation of early Hunters, which was modest range due to limited internal fuel capacity and early turbojets' thirsty fuel consumption. The ability to carry external drop tanks substantially extended operational radius and tactical flexibility. The Hunter F-6, which appeared in 1956, represented the definitive single-seat fighter variant. Powered by the Avon 203 engine producing 10,000 pounds of thrust, the F-6 featured increased internal fuel capacity, provision for a wider variety of external stores including rockets and bombs, improved systems including a more capable electrical system, and various detail refinements. The F-6 became the primary RAF Hunter variant, equipping numerous fighter squadrons through the late 1950s and into the 1960s. Over 380 F.6 aircraft were produced, and this variant achieved the greatest export success. The Hunter FGA.9 fighter ground attack variant, introduced in 1960, incorporated strengthened wings capable of carrying heavier external loads, provision for underwing bombs, rockets, and fuel tanks, and modifications optimizing the aircraft for low-level operations. The FGA-9, along with the similar FR-10 reconnaissance fighter, served with the RAF through the early 1970s, providing close air support and tactical reconnaissance capability. These ground attack Hunters participated in numerous operations including counterinsurgency campaigns in the Middle East and Africa. The Hunter T-7 two-seat trainer, featuring side-by-side seating in a widened forward fuselage, became the standard RAF advanced jet trainer from 1958. The T-7 retained full combat capability despite the second seat, mounting 430mm cannon and provision for external stores. This dual role as both advanced trainer and combat-capable aircraft provided excellent value, and the T-7 served the RAF through the early 1990s, significantly longer than single-seat fighter variants. The Hunter achieved remarkable export success, serving with over 20 air forces including Belgium, Chile, Denmark, India, Iraq, Jordan, Kenya, Kuwait, Lebanon, Netherlands, Oman, Peru, Qatar, Rhodesia, Saudi Arabia, Singapore, Somalia, Sweden, Switzerland, and Zimbabwe. Several nations established licensed production, with Fokker in Netherlands, Ferry in Belgium, and Hindustan Aeronautics in India, building Hunters domestically. Total production exceeded 1,900 aircraft, a remarkable figure for a post-war British combat aircraft and testament to the Hunter's international appeal. The Hunter saw extensive combat with multiple operators, compiling a distinguished combat record. During the 1956 Suez Crisis, RAF Hunters flew ground attack missions against Egyptian targets, demonstrating effectiveness in the fighter-bomber role. Indian Air Force Hunters participated in the 1965 and 1971 Indo-Pakistani Wars, engaging Pakistani F-86 Sabres and F-104 starfighters with some success. Jordanian Hunters fought in the 1967 Six-Day War against Israeli aircraft. Iraqi Hunters saw action in various regional conflicts, Perhaps most extensively, Rhodesian Hunters were heavily used during the Rhodesian Bush War from the mid-1960s through 1979, flying thousands of ground attack sorties in counterinsurgency operations. Swiss Hunters flew air defense missions protecting Swiss neutrality throughout the Cold War, though never engaging hostile aircraft. The cumulative combat experience demonstrated the Hunter's versatility and effectiveness across diverse operational environments and mission types. The Hunter established numerous records and achievements. In 1953, a Hunter F-3 set a world airspeed record of 727.6 miles per hour, bringing the record back to Britain after American F-86 Sabres had held it. Hunter pilots won numerous aerobatic competitions, with the aircraft's superb handling making it a favorite for formation aerobatics. The RAF's aerobatic teams, including the Black Arrows and later the Blue Diamonds, flew Hunters, with the Black Arrows performing a famous loop of 22 Hunters in formation at the 1958 Farnborough Air Show, a record that still stands. These public demonstrations showcased British aviation prowess and provided exceptional publicity. The Hunter's RAF service as a frontline fighter ended in the early 1970s as more capable aircraft, including the Lightning Interceptor and Phantom multi-role fighter, replaced it. However, Hunters continued serving the RAF in training and secondary roles through 1994, when the last T-7 trainers were finally retired after nearly 40 years of service. Export operators flew Hunters even longer, with the Lebanese Air Force operating the last Hunters until 2014, 60 years after the type entered service. The English Electric Canberra represents one of the most successful British aircraft designs of the post-war era, serving as a tactical bomber, reconnaissance platform, electronic warfare aircraft, and test bed in numerous configurations with air forces worldwide. The Canberra's longevity is remarkable, with some variants remaining in service over 60 years after the first flight, making it one of the longest-serving military aircraft designs in history. The aircraft's versatility, reliability, and performance made it a valuable asset across diverse missions and environments. Development of the Canberra began in 1945 as the Air Ministry sought a jet-powered replacement for the Mosquito light bomber. The specification called for a high-altitude bomber capable of delivering a 10,000-pound bomb load and outrunning contemporary fighters, making defensive armament unnecessary. English Electric, a company better known for locomotives and electrical equipment than aircraft, submitted a design powered by two Rolls-Royce Avon turbojet engines mounted in the wing roots. The clean design with smooth lines and minimal protrusions optimized aerodynamics for high-altitude, high-speed flight. The prototype VN799 first flew on May 13, 1949, and demonstrated excellent performance. The aircraft could reach altitudes exceeding 48,000 feet, well beyond the ceiling of most contemporary fighters, and cruise at speeds around 470 miles per hour at altitude, adequate to outrun many interceptors. The handling characteristics proved pleasant, with none of the vicious tendencies of some early jets. Visibility from the cockpit was excellent thanks to the extensive glazing of the nose section. The Canberra quickly demonstrated that it met or exceeded all specification requirements. The Canberra B-2 entered RAF service with No. 101 Squadron in May 1951, remarkably rapid development from first flight to operational service. The B-2 featured a crew of 3, including pilot, navigator, and bomb aimer, internal bomb bay capable of carrying various ordnance loads up to 10,000 pounds, no defensive armament relying on speed and altitude for protection, and powered by Avon 101 engines producing 6,500 pounds of thrust each. The aircraft's maximum speed of approximately 580 miles per hour at altitude and service ceiling, exceeding 48,000 feet, gave it performance advantages over most interceptors of the early 1950s. The Canberra B-6, introduced in 1954, featured more powerful Avon 109 engines, provision for underwing fuel tanks or bombs, and various detail improvements. This became the primary RAF bomber variant, equipping numerous squadrons through the 1950s and early 1960s. The Canberra BI.8 interdictor variant featured a solid nose mounting 420mm cannon and provision for underwing rockets or bombs, optimizing the aircraft for low-level attack missions. This variant served primarily in Germany and Far East, providing tactical strike capability. The Canberra PR-3 photo reconnaissance variant, with cameras installed in the bomb bay and additional fuel in place of armament, entered service in 1952. The PR-7 and PR-9 reconnaissance variants featured increasingly sophisticated camera installations and extended wings increasing span from 64 feet to 67 feet on the PR-9, enhancing high-altitude performance. These reconnaissance cameras provided the RAF's primary tactical reconnaissance capability for decades, with the PR-9 serving until 2006, 57 years after the prototype's first flight. The Canberra achieved remarkable export success, serving with over 15 air forces including Argentina, Australia, Chile, Ecuador, Ethiopia, France, India, New Zealand, Peru, Rhodesia, South Africa, Sweden, Venezuela, and Zimbabwe. Most significantly, the United States Air Force selected the Canberra for licensed production as the Martin B-57, with over 400 built in America. This represented a rare instance of the U.S. adopting a foreign military aircraft design, testament to the Canberra's capabilities. Various specialized B-57 variants served the USAF into the 1980s, including electronic warfare versions that operated in Vietnam and later conflicts. The Canberra saw extensive combat service with multiple operators. During the 1956 Suez Crisis, RAF Canberras conducted bombing raids against Egyptian airfields, suffering losses to Egyptian anti-aircraft fire. Indian Air Force Canberras participated in the 1965 and 1971 Indo-Pakistani Wars, conducting bombing raids and reconnaissance missions. Argentine Canberras operated during the 1982 Falklands War, conducting long-range strikes against British forces. Several were shot down by Sea Harriers and surface-to-air missiles, demonstrating the aircraft's vulnerability when facing modern air defenses. But the survivors continued operating throughout the conflict, showing remarkable resilience. Rhodesian Canberras flew ground attack missions during the Rhodesian Bush War. Various other operators employed Canberras in conflicts and skirmishes, generally finding the aircraft effective for tactical bombing and reconnaissance when operating against opponents lacking sophisticated air defenses. Perhaps the most famous Canberra operation was the high-altitude reconnaissance flights over the Soviet Union and Eastern Europe during the Cold War. RAF Canberra PR-7 reconnaissance aircraft conducted overflight missions, photographing Soviet military installations before the U-2 spy plane assumed this role. These highly dangerous missions penetrated Soviet airspace at extreme altitudes, relying on the Canberra's ceiling to remain above most interceptors and surface-to-air missiles. Several Canberras were shot down during these operations, and crew members were killed or captured, demonstrating the risks of Cold War intelligence gathering. The Canberra served the RAF in various roles through 2006, when the last PR-9 reconnaissance aircraft were finally retired after 57 years of service. Specialized variants, including target towing aircraft and electronic warfare platforms, continued operating even longer. Export operators flew Canberras into the 21st century, with the Indian Air Force retiring its last Canberras in 2007. The aircraft's longevity is exceptional, comparable only to a handful of other designs like the B-52 bomber and C-130 transport that have achieved similar service lives through extensive modifications and upgrades. The Canberra's significance extends beyond its operational record. It demonstrated that British aviation industry could create aircraft with genuine export appeal, with the American license production representing a particular triumph. The aircraft's versatility allowed it to serve effectively in roles far beyond the original bomber mission, with reconnaissance, electronic warfare, and specialized variants exploiting the basic airframe's qualities. The Canberra proved that jet bombers could be reliable and maintainable in field conditions, lacking the temperamental qualities of some early jets. The export success and longevity of service provided British aerospace with valuable revenue and established relationships with foreign air forces. The Canberra showed that an aircraft designed to meet specific requirements rather than attempting to be all things to all users could achieve success and longevity by doing its primary mission exceptionally well. The Supermarine Swift represents one of British aviation's most disappointing post-war programs, A swept-wing fighter that promised much but delivered little, suffering from development problems that were never fully resolved and resulting in brief, troubled service. The Swift's failure demonstrates the challenges of developing high-performance fighters and the perils of rushing aircraft into service before problems are adequately addressed. Yet the Swift also contributed to British aviation knowledge, with the lessons learned informing subsequent programs, including the highly successful Hawker Hunter. Development of the Swift began as a swept-wing evolution of the Supermarine Attacker, a straight-wing naval fighter that itself had mixed success. Supermarine, still basking in the glory of its legendary Spitfire and hoping to build on that legacy, designed a swept-wing fighter around the Rolls-Royce Avon engine. The design incorporated 40-degree wing sweep, a single Avon turbojet, an armament of 430mm Aden cannons. The prototype Type 5-101st flew in 1948, but development proved problematic from the outset. The Swift suffered from numerous aerodynamic issues, including poor high-speed handling characteristics, pitch-up problems where the aircraft would suddenly nose up uncontrollably, unpredictable stall behavior, and inadequate longitudinal stability. These problems reflected incomplete understanding of swept-wing aerodynamics and insufficient wind tunnel testing before committing to the design. Various modifications attempted to address these issues, including changes to wing shape, addition of fences on the wings, modifications to tail surfaces, and other aerodynamic fixes. However, the fundamental problems were never entirely resolved. Despite the ongoing development difficulties, pressure to equip the RAF with swept-wing fighters led to the Swift being ordered into production before problems were adequately addressed. The Swift F1, powered by the Avon 109 engine producing 7,500 pounds of thrust, entered service with No. 56 Squadron in February 1954. The aircraft's maximum speed exceeded 690 miles per hour at sea level, making it one of the fastest fighters in service. However, operational experience quickly revealed serious deficiencies. The Swift F1 suffered from poor climb rate, inadequate high-altitude performance compared to competing interceptors, unreliable gun installation with frequent jamming, limited ammunition capacity, and persistent aerodynamic issues that made the aircraft demanding to fly. Pilots reported that the Swift required constant attention and was unforgiving of mistakes, a dangerous combination in a fighter aircraft. The type was withdrawn from squadron service after only a few months, a humiliating failure for both the RAF and Supermarine. The Swift F2, incorporating a variable incidence tailplane and other modifications attempting to address handling problems, achieved only slightly better results. The Swift F3, which never entered service, would have featured rocket engines to improve climb rate, but development was abandoned as the program's problems mounted. The Swift F4, with reheat engines providing additional thrust, showed some improvement, but still suffered from inadequate performance and reliability issues. The Swift FR-5 fighter reconnaissance variant represented the only moderately successful Swift, with cameras installed in the nose, provision for underwing stores, and the aircraft optimized for low-level operations where its high speed was advantageous. The FR-5 served with several squadrons in Germany from 1956 through 1961. In the low-level reconnaissance role, where the Swift's high-speed performance was valuable and the high-altitude limitations were less relevant, the aircraft provided useful service. However, the FR-5's career was still brief compared to the Hawker Hunter, which filled similar roles with far greater success. The Swift F-7, a high-altitude interceptor variant with extended wings, reheat engines, and provision for guided weapons, represented an attempt to salvage something useful from the program. However, by the time the F-7 was ready, the English Electric Lightning was in development with performance that would render the Swift completely obsolete. The F-7 never entered squadron service, though prototypes flew and contributed some useful research data. Total Swift production reached approximately 200 aircraft across all variants, a tiny number compared to the nearly 2,000 Hawker Hunters produced. The Swift achieved no export sales, no nation beyond Britain having any interest in acquiring the troubled fighter. The brief service life and limited production made the Swift program an expensive failure that consumed resources while delivering minimal capability to the RAF. The Swift's failure had significant repercussions. It damaged Supermarine's reputation, contributing to the company's eventual absorption into other British aerospace firms. The Swift demonstrated the dangers of political pressure to rush aircraft into service before development was complete, with the premature deployment of the F-1 resulting in embarrassment and wasted resources. The program showed that even legendary aircraft manufacturers could produce failures, with Supermarine's Spitfire heritage offering no guarantee of success with jets. Most significantly, the Swift's problems diverted resources and attention from more promising programs, representing an opportunity cost beyond the direct program expenditures. However, the Swift was not entirely without value. The aircraft contributed to understanding of swept-wing aerodynamics, with the problems encountered and solutions attempted informing subsequent British fighter development. Test flying of Swifts provided valuable data on high-speed flight characteristics. Various research programs utilizing Swift airframes contributed to aerospace knowledge. Some innovations, including the variable incidence tailplane, while insufficient to save the Swift, were successfully applied to other aircraft. The Swift's failures provided lessons that helped ensure subsequent British fighters avoided similar mistakes. The Swift represents a cautionary tale in aviation history. It demonstrates that good intentions, talented engineers, and heritage from past successes cannot guarantee success when fundamental design issues are not adequately addressed before production commitment. The Swift shows the importance of thorough testing and development before entering service, and the dangers of political pressure compromising technical decision-making. The contrast between the Swift's failure and the Hunter's success, despite both being swept-wing fighters from established manufacturers and entering service at similar times, illustrates how small differences in design execution can produce vastly different outcomes. The Swift remains a footnote in British aviation history, remembered primarily as a failure that contrasts sharply with the triumphs of the Hunter and other successful British fighters. The English Electric Lightning represents the pinnacle of British fighter interceptor design, a spectacular performer that combined breathtaking acceleration and climb rate with sustained supersonic capability, making it one of the most impressive fighters of its era. The Lightning's distinctive configuration with vertically stacked engines and dramatic performance made it instantly recognizable, while its service as the RAF's primary air defense fighter from 1960 through 1988 demonstrated both capabilities and limitations. The Lightning was beloved by its pilots for spectacular performance, but criticized by some observers for limited range and weapons capability, reflecting the compromises inherent in 1950s interceptor design philosophy. Development of the Lightning began in the early 1950s as the RAF sought a supersonic interceptor capable of defending British airspace against high-altitude Soviet bombers. The specification called for exceptional climb rate to reach altitude quickly, sustained supersonic speed to intercept fast targets, and capability to engage bombers beyond visual range using guided missiles. English Electric's design team, led by WEW created a radical configuration featuring two Rolls-Royce Avon turbojet engines mounted vertically in the fuselage, one above the other, an arrangement dictated by the need to minimize frontal area and reduce drag while providing sufficient thrust. The prototype P-1A first flew on August 4, 1954, and quickly demonstrated remarkable performance, exceeding Mach 1 in level flight during early testing. The refined P-1B prototype, closer to the production configuration, first flew in April 1957 and achieved Mach 2, double the speed of sound, in November 1958, making it one of the first aircraft capable of sustained supersonic flight. The dramatic acceleration and climb rate impressed everyone who witnessed it, with the Lightning capable of reaching 40,000 feet in less than 3 minutes from brake release, performance that remained exceptional decades later. The Lightning F-1, powered by two Avon 210 engines, with reheat producing 14,430 pounds of thrust each, entered RAF service with No. 74 Squadron in June 1960. The aircraft's maximum speed exceeded Mach 2.0 at altitude, making it one of the fastest fighters in service anywhere in the world. Initial armament consisted of two 30mm ADN cannons and two Firestreak infrared-guided air-to-air missiles, providing capability to engage targets beyond visual range. The aircraft's exceptional climb rate and acceleration made it ideally suited for the point defense interceptor role, scrambling to altitude to engage incoming bombers. The Lightning F-2, introduced in 1962, featured fully variable reheat nozzles, replacing the simple two-position nozzles of the F-1, improving fuel efficiency and extending range. However, range remained the Lightning's Achilles heel. The powerful engines consume fuel voraciously, especially when using reheat, limiting combat radius to approximately 350 nautical miles without external tanks. This was adequate for defending British airspace but constrained operational flexibility and would have been problematic for extended patrol missions. The Lightning F-3, entering service in 1964, incorporated more powerful Avon 301 engines producing 16,360 pounds of thrust each, improved red-top infrared guided missiles with superior range and guidance compared to Firestreak, a larger ventral fuel tank increasing internal fuel capacity, squared-off fin tip housing radar warning receiver, and deletion of the cannon armament, reflecting the philosophy that missiles alone were sufficient for interceptor missions. The F-3 became the primary RAF Lightning variant, equipping most interceptor squadrons. The Lightning F-6, the ultimate development, featured enlarged overwing fuel tanks, dramatically increasing fuel capacity, kinked and cambered wing leading edge, improving high-speed handling, ventral tank extended and given better streamlining, and provision for overwing or overwing ferry tanks for deployment flights. The F-6's improved fuel capacity significantly extended range and time on station, addressing the most significant criticism of earlier Lightnings. However, F-6 production totaled only 62 aircraft, with most RAF Lightning squadrons operating earlier variants. The Lightning never saw combat with the RAF, though it performed its air defense mission continuously for nearly 3 decades. RAF Lightning squadrons maintained quick reaction alert, with aircraft on runway standby ready to scramble within minutes to intercept unidentified aircraft approaching British airspace. During the Cold War, Lightnings regularly intercepted Soviet reconnaissance aircraft and bombers, probing British air defenses, demonstrating their capability in deterring incursions. The dramatic performance and rapid response capability made the Lightning an effective deterrent, with Soviet aircraft learning to respect the capabilities of RAF interceptors. The Lightning achieved modest export success, serving with the Royal Saudi Air Force and Kuwait Air Force. Saudi Arabia purchased over 40 Lightnings of various marks, including unique export variants with additional fuel capacity in different systems. Kuwait operated a small number of Lightnings for air defense. However, the limited export sales reflected the Lightning's specialized nature and high operating costs, with most nations seeking more versatile multi-role fighters rather than dedicated interceptors. The Lightning's operational service demonstrated both capabilities and limitations. The exceptional performance and climb rate made it unmatched for the point defense interceptor mission, with the ability to scramble and reach altitude faster than any contemporary fighter. The sustained supersonic capability allowed engagement of high-speed targets. The missile armament provided beyond visual range engagement capability, though the early missiles were somewhat unreliable. However, the limited range constrained missions, the lack of cannon armament on later variants was controversial among pilots who valued guns for close combat. The two-dimensional radar provided only basic intercept capability compared to more sophisticated systems on contemporary American fighters. And the specialized interceptor design made the Lightning unsuitable for ground attack or other roles, limiting versatility. The Lightning's pilots universally praised the aircraft's flying qualities and performance. The acceleration was described as spectacular, with the Lightning's thrust-to-weight ratio giving it performance few other fighters could match. The handling characteristics were generally good, though the aircraft could be demanding at low speeds and high angles of attack. Visibility from the cockpit was excellent. The aircraft was loud, fast, and dramatic, characteristics that endeared it to pilots and airshow audiences alike. The Lightning became a favorite of airshow performers, with its rapid climb to altitude followed by dramatic high-speed passes, showcasing capabilities no other British fighter could match. The Lightning's RAF service ended in 1988 as the Panavia Tornado F-3 replaced it as the primary air defense fighter. The Lightning had served nearly 3 decades, a respectable career, though shorter than some contemporaries. The specialized interceptor design meant that as the Cold War evolved and requirements shifted toward multi-role capability, the Lightning's limitations became more apparent. Nevertheless, the Lightning successfully performed its intended mission for decades and remains one of the most spectacular fighters Britain ever produced. The Lightning's significance in British aviation history is substantial. It demonstrated that British aerospace could develop supersonic fighters with world-class performance, matching or exceeding American and Soviet capabilities in specific regimes. The Lightning represented the peak of British independent fighter development, with subsequent British fighters being either foreign designs like the Phantom or collaborative programs like the Jaguar, Tornado, and Typhoon. The aircraft showed British engineering at its most ambitious, creating a unique configuration that delivered exceptional performance. The Lightning proved that specialized interceptors could be highly effective in their intended role, even if limited versatility compared to multi-role fighters. For a generation of aviation enthusiasts and RAF pilots, the Lightning represents the ultimate British fighter, a dramatic and spectacular performer that exemplified the romance of Cold War jet fighters before sophisticated avionics and beyond visual range combat changed fighter design philosophy fundamentally. The Avro Vulcan represents one of the most iconic British aircraft of the Cold War era, a strategic bomber with a distinctive delta wing planform and stunning appearance that made it instantly recognizable. The Vulcan served as the primary British nuclear deterrent for over a decade before that role passed to submarine-launched missiles, then continued serving in conventional bombing and maritime radar reconnaissance roles through the 1980s. The Vulcan's distinctive howl from its 4 Olympus engines and graceful appearance despite its size made it a favorite of airshow audiences, while its combat debut during the Falklands War at the end of its career demonstrated capabilities and highlighted the challenges of long-range conventional bombing. The Vulcan originated from a 1947 Air Ministry specification for a high-altitude strategic bomber capable of carrying nuclear weapons and penetrating Soviet air defenses. The specification called for range to reach targets deep in the Soviet Union, ability to carry a 10,000-pound nuclear weapon, and performance to evade contemporary interceptors. Avro's chief designer, Roy Chadwick, created a revolutionary design featuring a broad delta wing planform, with the wing comprising most of the aircraft's lifting surface and containing fuel tanks, engines, and undercarriage. The pure delta configuration was radical, with few precedents, but offered low drag at high altitude and good high-speed characteristics. The prototype VX-770 first flew on August 30, 1952, and demonstrated that the delta configuration worked as predicted. The distinctive howl from the 4 Bristol Olympus turbojet engines buried in the wing roots became the Vulcan's signature sound. The aircraft's handling proved surprisingly nimble for its size, with test pilots describing it as fighter-like in responsiveness. The pure white anti-flash paint scheme, designed to reflect thermal radiation from nuclear explosions, gave the Vulcan a futuristic, otherworldly appearance. The Vulcan B-1, powered by 4 Olympus 101 or 104 engines producing 11,000 to 13,000 pounds of thrust each, entered RAF service with No. 83 Squadron in July 1956. The aircraft featured a crew of 5, including 2 pilots, navigator radar, navigator plotter, an air electronics officer, internal bomb bay capable of carrying nuclear weapons or conventional bombs up to 21,000 pounds, electronic countermeasures equipment to jam enemy radars and defenses, and maximum speed of approximately 645 miles per hour at altitude. The service ceiling exceeded 55,000 feet, placing the Vulcan above most contemporary interceptors and surface-to-air missiles. The Vulcan B-2, the definitive variant, incorporated significantly more powerful Olympus 201 or 301 engines, producing 17,000 to 20,000 pounds of thrust, redesigned wing with extended span and kinked leading edge, improving high-speed handling, stronger structure allowing higher operating weights, improved electronic countermeasures suite, and provision for blue steel standoff nuclear missile, allowing the Vulcan to launch weapons from outside enemy defenses. The B-2 entered service in 1960 and represented a substantial improvement over the B-1, which was relatively quickly withdrawn from bomber role and relegated to training. The Vulcans served as the airborne component of Britain's independent nuclear deterrent throughout the 1960s. Vulcans maintained quick reaction alert at various RAF stations, loaded with nuclear weapons, and ready to launch within minutes if ordered. The aircraft's range, allowing it to reach targets throughout the Soviet Union when supported by air-to-air refueling, and ability to carry multiple nuclear weapons made it a credible deterrent. The Blue Steel standoff missile, while criticized for limited range and reliability, provided some capability to attack without overflying targets and exposing the aircraft to the heaviest defenses. The Vulcan fleet represented Britain's guarantee of independent nuclear retaliation capability, ensuring that Britain could not be coerced by nuclear threats. As the 1960s progressed, improvements in Soviet air defenses, including high-altitude surface-to-air missiles and sophisticated radar systems, made high-altitude penetration increasingly dangerous. The Vulcan's mission profile changed to low-level penetration, using terrain masking and electronic countermeasures to avoid detection and survive to weapon release. This required modifications including terrain-following radar, strengthened structure for low-level turbulence, and camouflage paint schemes replacing the distinctive white finish. The transition to low-level operations imposed greater stress on the airframes and represented tacit admission that the original high-altitude penetration concept was obsolete. In 1969, the British government decided to transfer the nuclear deterrent role from RAF bombers to the Royal Navy's Polarity submarine-launched ballistic missile force. This decision, driven by concerns about bomber survivability and the invulnerability of submarine-based deterrents, removed the Vulcan's primary mission. However, rather than immediately retiring, the Vulcan continued serving in conventional bombing and maritime radar reconnaissance roles. Some Vulcans were modified for maritime surveillance, equipped with radar to detect surface ships and provide targeting data for naval operations. The Vulcan's combat debut came during the 1982 Falklands War, when RAF Vulcans conducted Operation Black Buck, a series of long-range bombing raids against Argentine forces occupying the Falkland Islands. These missions, flown from Ascension Island in the mid-Atlantic, covered approximately 3,900 miles each way, requiring multiple air-to-air refueling contacts and representing some of the longest-range combat missions ever flown. The raids targeted the runway at Port Stanley Airport and Argentine radar installations, attempting to restrict Argentine air operations from the islands. The Black Buck missions demonstrated both the capabilities and limitations of long-range conventional bombing. The Vulcans successfully reached the target area and delivered weapons, a remarkable achievement requiring precisely coordinated aerial refueling and overcoming numerous technical challenges. The psychological impact of the raids on Argentine forces was significant, demonstrating that Britain could strike the islands despite the vast distance. However, the actual physical damage inflicted was limited, with the runway raids cratering the runway, but not rendering it unusable for the light aircraft Argentina was operating, and only one of 21 bombs dropped hitting the runway. The radar suppression missions using AGM-45 Shrike anti-radiation missiles were more successful. The missions required enormous support, with multiple Victor tanker aircraft required to refuel both the Vulcan bombers and the tankers themselves, representing a massive effort for limited physical results. The Vulcan's RAF service ended in 1984, with the type officially retiring after over 28 years of service. The end of the Cold War and introduction of more capable aircraft, including the Tornado, made the aging Vulcan obsolete. One aircraft, XH-558, was kept flying for display purposes and later restored to flight by a private organization, becoming the world's only flying Vulcan and delighting airshow audiences until finally grounded in 2015 due to age and cost of maintaining airworthiness. The Vulcan achieved no export sales, the strategic bomber mission being of interest only to major powers, and Britain's NATO allies relying on American strategic forces for nuclear deterrence. Total production of all Vulcan variants reached 136 aircraft, adequate for Britain's needs but tiny compared to American bomber production numbers. The Vulcan's significance extends beyond its operational record. It demonstrated British engineering's ability to create revolutionary designs, with the pure Delta configuration being radical when introduced. The Vulcan represented Britain's commitment to independent nuclear deterrent capability, providing a credible deterrent force during the height of the Cold War. The aircraft's distinctive appearance and impressive aerial displays made it a symbol of British aerospace prowess, with the howling Olympus engines and graceful delta shape becoming iconic. The Black Buck missions demonstrated British determination and capability to project power globally, even if the military effectiveness was limited. The Vulcan remains one of the most recognizable and admired British aircraft, representing an era when Britain developed strategic systems independently and maintained great power military capabilities. For many aviation enthusiasts, the Vulcan epitomizes Cold War aviation, a spectacular and impressive machine that thankfully never had to perform its primary nuclear mission, but served as an effective deterrent for over a decade. The Hawker Siddeley Harrier represents one of the most revolutionary aircraft designs in aviation history, the world's first practical vertical/short takeoff and landing jet aircraft to achieve operational service. The Harrier's ability to operate from unprepared sites, short runways, and even small naval vessels without catapults or arresting gear provided capabilities no conventional aircraft could match. The Harrier proved itself in combat during the Falklands War and served with the RAF, Royal Navy, United States Marine Corps, and other forces for decades, validating the VSTOL concept despite skeptics who questioned its utility. The Harrier's origins trace to Sidney Cam's design team at Hawker Aircraft and the development of the Bristol Siddeley Pegasus vectored thrust turbofan engine. The concept was straightforward in principle, but extraordinarily difficult to implement. A jet engine with rotating nozzles that could direct thrust downward for vertical takeoff and landing or aft for conventional forward flight. The Pegasus engine featured 4 rotating nozzles, 2 for cold bypass air and 2 for hot jet exhaust, allowing thrust to be vectored through approximately 98 degrees from fully aft to slightly forward. The aircraft design surrounding this engine needed to balance the thrust precisely to avoid tumbling or instability during vertical flight while providing adequate fuel capacity and payload capability to be militarily useful. The prototype P1127, as it was initially designated, first flew conventionally on October 21, 1960, and achieved its first hovering flight in November 1960. The early testing demonstrated the feasibility of vectored thrust flight, but also revealed the challenges of controlling an aircraft balancing on jet thrust with no aerodynamic surfaces providing control. A reaction control system using jets of bleed air at the nose, tail, and wingtips provided attitude control during hover and transition, supplementing conventional aerodynamic controls that only worked once the aircraft was moving through the air at sufficient speed. Development proceeded through several stages, including the Kestrel evaluation aircraft that 6 nations, including the United States, tested in the mid-1960s. The experience gained from Kestrel operations informed the development of production Harrier variants. The Harrier GR1, the initial RAF variant, entered service with number 1 Squadron in April 1969. Powered by the Pegasus 101 vectored thrust turbofan producing 19,000 pounds of thrust, the GR1 featured a maximum speed of approximately 730 miles per hour at low level, combat radius of about 260 nautical miles with typical weapons load, an armament of 230mm Aden cannons, plus up to 5,000 pounds of external stores on 5 hardpoints. The aircraft's crew consisted of a single pilot, and the small size and relatively modest payload reflected the compromises necessary to achieve VSTOL capability. The Harrier's operational concept differed fundamentally from conventional fighters. Rather than operating from large, vulnerable air bases with long runways that would be priority targets in wartime, Harriers could disperse to small forward sites hidden in forests or near front lines. A small clearing in woods, a section of straight road, or a small prepared pad provided sufficient operating space. Ground crews and supplies deployed with the aircraft, creating mobile detachments that could support operations away from fixed bases. This dispersed basing concept promised survivability against attack and the ability to operate from sites close to battle areas, reducing transit time to target areas. The Harrier GR3, introduced in the mid-1970s, featured an uprated Pegasus 103 engine producing 21,500 pounds of thrust, a laser rangefinder and marked target seeker in the nose, improved avionics and weapons delivery systems, and better radar warning receiver. The GR3 represented an incremental improvement over early variants, enhancing combat effectiveness and survivability. The Sea Harrier, a specialized variant developed for the Royal Navy Fleet Air Arm, featured a raised cockpit providing better visibility, Blue Fox radar and a revised nose, allowing beyond visual range engagement and anti-ship missile guidance, revised avionics for naval operations, and modifications for operating from aircraft carriers. The Sea Harrier FRS-1 entered Royal Navy service in 1980, providing a credible fighter and reconnaissance capability for the small carriers of the Invincible class that lacked catapults or arresting gear and could not operate conventional fixed-wing aircraft. The Harrier and Sea Harrier achieved their combat debut during the 1982 Falklands War, and the performance validated the VSTOL concept dramatically. Sea Harriers from HMS Hermes and HMS Invincible flew combat air patrols protecting the British task force, providing the only fighter cover available over 8,000 miles from Britain. RAF Harrier GR3S operated from the carriers as well, conducting ground attack missions against Argentine positions. The Sea Harrier's combat record during the Falklands War was exceptional. Sea Harrier pilots flew over 2,000 sorties during the conflict and claimed 20 air-to-air victories against Argentine aircraft, including Mirages, Skyhawks, and Pucarás, without suffering a single air-to-air loss, an unprecedented kill ratio. The victories were achieved using AIM-9 Sidewinder infrared-guided missiles and 30mm cannon, with the vectoring thrust capability allowing Harrier pilots to maneuver in ways conventional fighters could not match. The tactic of vectoring in forward flight, using the nozzles to decelerate rapidly and cause pursuing aircraft to overshoot, proved effective in several engagements. The Harrier GR3S conducted over 150 ground attack sorties, providing close air support despite operating in challenging conditions with limited support. The combat success during the Falklands generated enormous interest in the Harrier. The ability to operate from small carriers without catapults or arresting gear had proven its worth, and the air combat performance exceeded expectations. However, the Falklands also highlighted limitations, including modest payload and range compared to conventional fighters, vulnerability to ground fire due to low-altitude operations, maintenance complexity of the vectored thrust system in field conditions, and limited beyond visual range combat capability due to basic radar and weapon systems. The Harrier II, a substantially redesigned development produced jointly by British Aerospace and McDonnell Douglas, addressed many limitations. The Harrier II featured a larger wing with increased area and modern supercritical airfoil, composite construction reducing weight, more powerful Pegasus engine, improved avionics and weapon systems, and increased payload capacity. The RAF's Harrier GR5, GR7, and GR9 variants based on the Harrier II design provided substantially improved capability over earlier Harriers, serving from the late 1980s through 2010. The United States Marine Corps became the largest Harrier operator, purchasing over 300 AV-8A, AV-8B, and AV-8B plus variants. The USMC concept of operations emphasized amphibious assault support, with Harriers operating from amphibious assault ships and forward sites near beachheads. Marine Harriers participated in operations during the Gulf War, Afghanistan, Iraq, and other conflicts, proving the concept of mobile tactical aviation supporting ground forces. RAF Harriers saw extensive combat after the Falklands. During the Balkans conflicts of the 1990s, RAF Harriers flew ground attack missions in Bosnia and Kosovo, operating from bases in Italy. In 2003, RAF and Royal Navy Harriers participated in Operation Iraqi Freedom, conducting strike missions. From 2004 through 2009, Harriers deployed to Afghanistan, providing close air support for ground forces from Kandahar airfield. The Afghan operations demonstrated the Harrier's versatility and effectiveness in counterinsurgency operations, though often operating conventionally from runways rather than exploiting VSTOL capability. The Harrier's RAF and Royal Navy service ended controversially in 2010 when the British government's Strategic Defence and Security Review decided to retire all Harriers immediately as a cost-saving measure. This decision, leaving Britain without carrier-based fixed-wing aircraft until the F-35B enters service, was widely criticized as short-sighted. The sudden retirement while Harriers were actively engaged in Afghanistan and the aircraft had substantial service life remaining seemed to many a false economy driven by financial desperation rather than military logic. The Harrier's significance in aviation history is immense. It proved that VSTOL jet aircraft could be practical and effective military systems, not merely experimental curiosities. The combat record, particularly during the Falklands, demonstrated capabilities that vindicated decades of development investment. The Harrier enabled small aircraft carriers to operate effective fixed-wing aircraft, maintaining capability that would otherwise require massive carriers with catapults and arresting gear. The aircraft demonstrated British innovation and engineering excellence, creating a capability that other nations attempted to copy but never successfully replicated in service. The Harrier proved that unconventional solutions could solve real military problems, providing capabilities conventional aircraft could not match. The influence of the Harrier continues, with the F-35B Lightning II incorporating STOVL capability, partially inspired by Harrier experience and designed to serve many of the same missions for the Royal Navy, U.S. Marine Corps, and other operators. The Harrier remains one of the most distinctive and innovative British aircraft, representing an engineering achievement that changed aviation history. The Seppicat Jaguar represents a successful Anglo-French collaborative aircraft program that produced an effective tactical strike and reconnaissance platform, serving both nations and achieving respectable export success. The Jaguar demonstrated that international collaboration could produce capable aircraft when partners had compatible requirements and managed programs effectively, lessons that would inform subsequent European collaborative programs, including Tornado and Typhoon. The Jaguar originated from separate British and French requirements in the early 1960s for advanced jet trainers. The British and French governments decided to combine development, creating a joint program managed by Seppicat, a company specifically established for the Jaguar, with Société des Avions, Marcel Dassault Breguet, and British Aircraft Corporation as partners. The original trainer requirement evolved during development into a more capable tactical strike aircraft, as both nations recognized the need for such a platform. The Jaguar design featured two Rolls-Royce Turbomeca Adore afterburning turbofan engines, swept wings optimized for high-speed low-level flight, sophisticated navigation and weapons delivery systems for accurate strike missions, and a relatively large internal fuel capacity for good range. The prototype first flew on September 8, 1968, and demonstrated good performance and handling characteristics. The Jaguar GR1, the RAF's tactical strike variant, entered service with No. 54 Squadron in 1973. Powered by two Adore 102 engines producing 8,040 pounds of thrust with afterburner, the GR1 featured a maximum speed exceeding Mach 1.1 at altitude and approximately 840 miles per hour at low-level combat radius of about 575 nautical miles with typical weapons load, and comprehensive avionics including inertial navigation system, head-up display, and laser rangefinder and marked target seeker. Armament consisted of two 30mm ADN cannons and 5 hardpoints capable of carrying various bombs, rockets, and missiles. The aircraft's crew consisted of a single pilot with excellent visibility from the cockpit canopy. The Jaguar GR1A and later GR3 and GR3A variants incorporated various improvements, including better avionics, more capable weapon systems, provision for overwing AIM-9, Sidewinder air-to-air missiles for self-defense, and improved radar warning receiver and countermeasure systems. These upgrades maintained the Jaguar's relevance through the 1980s and into the 1990s, substantially longer than originally intended. The Jaguar served the RAF primarily in the tactical strike role, with Jaguars based in Germany during the Cold War, ready to conduct interdiction missions against Warsaw Pact forces if conflict erupted. The Jaguar's ability to operate at high speed and low level, using terrain masking to avoid detection, made it well suited for penetrating defended airspace to attack targets including armor concentrations, airfields, and supply lines. The accurate navigation and weapons delivery systems allowed precise attacks on small targets, important for tactical strike missions where collateral damage needed to be minimized. The Jaguar saw extensive combat service with the RAF. During Operation Granby, the RAF contribution to the 1991 Gulf War, Jaguars conducted reconnaissance and strike missions against Iraqi forces. The aircraft performed well in the desert environment, flying hundreds of sorties with several aircraft damaged by ground fire, but all returning safely. The Jaguar demonstrated its versatility by conducting both pre-planned strikes against fixed targets and armed reconnaissance missions, searching for mobile targets. Throughout the 1990s, RAF Jaguars participated in operations enforcing the no-fly zones over Iraq, conducting reconnaissance and strike missions. The Jaguar was involved in numerous operations over Bosnia and Kosovo during the Balkans conflicts, attacking targets in support of NATO operations. In 2003, Jaguars participated in Operation Iraqi Freedom, conducting strikes during the invasion of Iraq. Throughout these operations, the Jaguar proved reliable and effective, with the accurate weapons delivery systems allowing precision attacks with unguided bombs when laser-guided weapons were unavailable or inappropriate. The Jaguar's final combat deployment came in 2007 in Afghanistan, where Jaguars provided reconnaissance capability for several months before returning to Britain. The Jaguar retired from RAF service in 2007 after 34 years, substantially longer than originally planned, and testament to successful capability upgrades, extending service life. The Jaguar achieved respectable export success, serving with the French Air Force as well as India, Ecuador, Nigeria, and Oman. India became the largest Jaguar operator beyond Britain and France, acquiring over 100 aircraft, including domestically produced examples built by Hindustan Aeronautics under license. Indian Jaguars remain in service today, substantially upgraded with modern avionics and weapon systems. The export sales demonstrated the Jaguar's competitiveness in international markets and provided important revenue for British and French aerospace industries. The French Air Force operated Jaguars in both tactical strike and reconnaissance roles, with French Jaguars participating in operations in Chad, Mauritania, and other former French colonies in Africa. French Jaguars also deployed to the Gulf War and various other operations, providing complementary capability to France's Mirage fighters. French Jaguars retired from service in 2005, slightly earlier than RAF examples. The Jaguar's significance includes demonstrating that Anglo-French collaboration could produce successful aircraft when managed properly, providing a capable tactical strike platform that served both nations well for decades, achieving respectable export success, and generating revenue for British and French industries, and establishing relationships and experience in collaborative programs that inform subsequent projects. The Jaguar proved that relatively modest aircraft designed for specific missions could be highly effective and cost-effective compared to more ambitious multi-role fighters. The aircraft's longevity, serving decades beyond original plans, demonstrated the value of capability upgrades maintaining relevance. For the RAF, the Jaguar filled an important niche in the force structure, providing tactical strike capability that complemented rather than duplicating capabilities of other aircraft types. The Panavia Tornado represents the most successful European collaborative combat aircraft program of the Cold War era, producing a sophisticated multi-role aircraft that served Britain, Germany, and Italy for decades in strike, reconnaissance, and air defense roles. The Tornado demonstrated that complex international collaboration could produce genuinely capable aircraft when partners maintained commitment despite challenges, shared development costs and risks, and compromised when necessary to maintain program unity. The Tornado originated from separate British, German, and Italian requirements in the late 1960s for a strike aircraft to replace aging fleets of Canberras, F-104 Starfighters, and F-84 Thunderstreaks. After initial studies including participation by other nations, Britain, Germany, and Italy committed to joint development, establishing Panavia Aircraft GmbH as the development organization with British Aerospace, Messerschmitt Bölkow Blohm, and Air Italia as partners. The Tornado design featured variable sweep wings, allowing optimization for different flight regimes, two Turbo Union RB199 afterburning turbofan engines, sophisticated terrain-following radar, enabling automatic low-level flight in darkness and bad weather, comprehensive avionics and weapon systems, and a crew of 2 seated in tandem with pilot and navigator/weapon system operator. The variable sweep wings could be set at 25 degrees for takeoff and landing and subsonic cruise, 45 degrees for general operations, 67 degrees for high-speed flight, or positions between as optimal for specific conditions. This complexity added weight and mechanical systems, but provided performance benefits across diverse flight regimes. The prototype flew on August 14, 1974, and development proceeded despite challenges including cost overruns, schedule delays, and disagreements among partners about specifications and production workshare. However, the program survived these difficulties and proceeded to production, with 3 national variants developed to meet each nation's specific requirements. The Tornado GR-1, the RAF's interdiction and strike variant, entered service with No. 9 Squadron in 1982. Powered by 2 RB-199 Mark 103 engines producing 16,075 pounds of thrust with afterburner, the GR-1 featured a maximum speed exceeding Mach 2 at altitude and approximately 920 miles per hour at low level. Combat radius of approximately 863 nautical miles with typical weapons load, and comprehensive avionics including terrain-following radar, enabling hands-off low-level flight at high speed in darkness and poor weather, laser rangefinder and marked target seeker, inertial navigation, and head-up display. Armament consisted of 2 27mm Mauser cannons and provision for various guided and unguided weapons on multiple hardpoints. The sophisticated systems represented a quantum leap compared to earlier RAF strike aircraft. The Tornado's primary mission was low-level penetration of heavily defended airspace to attack high-value targets including airfields, bridges, and supply lines. The terrain-following radar, coupled with the Tornado's low-level performance, allowed the aircraft to operate at very low altitudes, using terrain masking to avoid radar detection and presenting minimal warning time to defenses. The weapon systems included JP-2-33 airfield attack weapons designed to crater runways and scatter anti-personnel mines, laser-guided bombs for precision attacks on bridges and hardened structures, and various conventional bombs and cluster munitions. The Tornado could deliver weapons with high accuracy while flying at 200 feet altitude and 600 miles per hour in complete darkness or bad weather, capabilities no previous RAF aircraft possessed. The Tornado GR-4, a substantially upgraded variant, incorporated forward-looking infrared sensor providing thermal imaging for target identification and weapon delivery, improved navigation and weapons delivery systems, capability for precision-guided munitions including GPS-guided weapons, enhanced defensive systems, and various other improvements. The GR-4 standard, which older GR-1s were upgraded to, transformed the Tornado into a precision strike platform capable of delivering guided weapons with high accuracy, reflecting the evolution from Cold War-era mass conventional attack to post-Cold War precision strike doctrine.